that. To refresh my memory, I started reviewing the report. There were systems that were unpatched for months. They had a yearly patching cycle. The entire network was flat. Some of their critical systems were running outdated Windows. It was basically a pen tester stream. So armed with that knowledge, I met with a customer around 10:30, 11 a.m. to start figuring out a plan for isolation. Well, within a couple of hours of network traffic analysis, we isolated the problem or the cause of the problem to a bunch of systems that have had a surge of network anomalous traffic over past couple of weeks. Now, many of these systems belonged to executives. So, as you can imagine, this issue was political now. Regardless, we decided to call those systems in to perform a deep forensic analysis. And while we were in the midst of it, around 1 p.m. or 1:30 p.m. that day, we got a call from one of their large health hospitals saying their patient intake systems are down and was showing the same error message, the banner that the backend systems were showing in the morning. And so their patient intakes, the whole process has now gone manual, which was a big issue because not only the process was inefficient, but also error prone. So needless to say, the focus shifted to get that process ready, to get those systems up. And while we were in the midst of it, around 4 p.m. or so, the same health hospital reported that the systems that manage their operation theater network, that was down as well. Same issue. But now, as you can imagine, from between 8:30 a.m. that morning to 5, 6 p.m. that afternoon, the threat has gone from the corporate data center all the way into the back ends of a hospital. So it has graduated. So regardless, we started focusing on getting this particular health system up, this hospital back into operation. But by 6:37 p.m. that night, we started getting calls from other hospitals as well that they are seeing the same issues. So now you can see that this threat has migrated from the corporate data center to their entire healthcare network and was causing the major pain. Now, I hope some of you can relate to it. And this story does have a happy ending, and no, they did not pay the ransom, and I will talk to you about it. But as you can see, this was a very challenging threat to handle. My name is Abi, and in the next 30 minutes or so, I'm going to show you how you can become proactive so this doesn't happen to you. We will talk about how ransomware has evolved from just being a minor annoyance into becoming a major extortion issue. We will talk about some of the frameworks that are out there that you can use to come up with your own strategy. We will also talk about how that framework would look like on AWS, so potential architecture. Then we will spend a considerable amount of time, like I said, on making you proactive, giving you the tools that you can use proactively handle this threat. So that being said, let's talk about how this threat has evolved and where it's heading. So ransomware gained notoriety around early 2000s, but back then the threat was local. It used to affect couple of well-known files. So your Word files, your PDF files, your zip files. And if you were to get infected, the ransom was a couple of $100. If you were unlucky enough, you would pay with a gift card. And attackers used to use tactics like your fake antivirus to infect you. Most cases, your antivirus software was able to detect it and was able to neutralize the threat. But a big change happened around 2013. This is a time when ransomware started getting featured in the national news cycles. For those who remember, CryptoLocker was one of them. This is when the attackers moved away and from the fake antivirus banners to now they are using the impersonation and scare tactics. And instead of going after some files on your network, on your systems, they started making your entire system servers unusable by encrypting the master boot record. And if you don't pay up, they would delete your data. But the scariest era started, in my opinion, around 2016. This is when the organized crime realized the potential of ransomware and stepped into it. Now, instead of going after a couple of servers, they started going after entire server farms, your IoT farms, your SAN devices. And instead of just simply deleting your files, attackers would now extort you for money. They would expose the data. Another big change that happened, which I believe is going to be in the future, which is going to decide the future as well, is the advent of ransomware as a service, the democratization of this thing, so that you don't need to have super skills. You can buy this thing on the dark web. So much so that now they are not blindly going after your assets. They know what they are very focused on the type of data they are going after. They are going after the financial documents, your tax data, your PIIs, and things that will hurt you the most. The threat has become so pervasive and so important that FBI is now involved in it. In 2019 alone, FBI got over 2,000 complaints and a reported loss of over $8.9 million. I read somewhere that crypto wall alone generated roughly around 20 to a couple of $100 million in revenue. So now the point and shoot approach that we have been used to in managing this threat is not going to be good enough. So we have to think about a very, very well thought out structured approach to handle ransomware. So if you think about it, what have we learned? None of these things should be a news to anyone. Now, the earlier we detect, the smaller the impact. We need to use threat intelligence, we need to use threat hunting to detect or to separate a smash and grab attack from a dedicated attacker. We need to segregate our networks, deploy least privilege, apply protection across all layers. We need to patch our systems. And if you are using features like auto scaling and launch templates, hopefully you are treating your servers like cattle rather than treating them like pets. And then go ahead and automate as much of it as you can so that eventually you can move over to a complete infrastructure as a code environment, especially in your production workloads. And then don't forget that users are a key part of the solution. So training the users is very, very important. All of these things are easier said than done. This can be expensive and time consuming. So when I ask this question to my customer that how do you know proactively that you are prepared to handle ransomware, I often hear 9 times out of 10 that this is too expensive. They are busy fighting fires. They do not know how to prevent or how to mitigate the threat. Even if they can detect it, they don't know how to go about it. To solve for this strategic gap, NIST, which is a US federal agency that creates the standards for US federal agencies and for critical sector companies, came up with a ransomware framework that described 9 core capabilities that you can use to come up with your own defensive strategy. So let's talk about those. Inventory management talks about keeping a track of the CIs that exist in your environment. On cloud, this is especially challenging or can be challenging because those CIs, the configuration items, are dynamic. A really helpful service here would be AWS config. Vulnerability management then talks about knowing the weaknesses that exist in your account and across your entire organization. This includes things like open CVEs on your AMIs as well as weak configurations, such as publicly exposed lambdas and very permissive security groups. A very useful service here would be AWS Inspector and Guard Duty and Security Hub as well. Policy enforcement then takes the data from inventory management and vulnerability management and sets the right set of protections on those assets. An example here would be lambdas that can remediate an overly permissive security group or a publicly exposed lambda attaching it to a VPC. Policy enforcement also deals with setting up the right set of protections or guardrails from your organization level. So things like AWS Control Tower, SCPs using AWS organizations, and IAM permission boundaries will help you set the right set of governance from the get-go. In integrity monitoring then talks about understanding what is in your environment and what it looks like. So the baselining of it. A very good service here that will be of use is SSM, Systems Manager. Logging and monitoring then talks about capturing the events that happen on your environment and then forwarding it over to a central account for safekeeping, and then only allowing break glass access to that account. On AWS, some of the commonly used services here would be AWS CloudTrail for API level logging, CloudWatch for system and application logging, and VPC for flow logs for network level logging. If you were to use Control Tower, like I mentioned before, CloudTrail and that centralized logging account with the right set of privileges would automatically be created